Today we're going to start our lesson on finding the future value of an annuity. Today's lesson, though, we're not going to be talking about annuities just yet, but we're going to talk about a mathematical principle that is useful to understand before we get to talking about annuities and how you can find the future value of an annuity. And that is geometric sequences. So what is a geometric sequence? A geometric sequence is a sequence of numbers where each term after the first is found by multiplying the previous one by a number which we call the common ratio. So here's an example of a geometric sequence: 3, -6, 12, -24, 48, and so on. Here you can see that to get to the next number, you always multiply by -2. So just so that we can see exactly what's going on here, we start off with some number, 3. Then to get to the next number, we do 3 times -2. And to get to the next one, we multiply that by -2. So this is really -2 to the second. And then the next, we have 3 times -2 to the third. And then 3 times -2 to the fourth. So in this case, we would say that the sequence of numbers is found by multiplying the previous one by -2. And we call -2 the common ratio. Now, if you're trying to determine the nth term of a geometric sequence, then you can use this formula. This formula comes in handy when you don't want to have to say in that last example, if you're trying to find the 50th term in the sequence, you don't want to have to find all the terms before it in order to get to that term. If you only want the 50th term, you can use this formula as long as you have what the first term is and you have the common ratio r. So A1 is what we call the first term of the sequence, and r is the common ratio. Take a look at example 1. Find the 7th term of the geometric sequence 5, 20, 80, 320. So we see here the first term is 5, and it looks like to get to the following term, you're multiplying by 4. Now to find the 7th term, this might actually be not terrible to go from the 4th term to the 7th term, but just for practice, we're going to use the formula. So we're finding A7, the 7th term. We know the first term is 5, and we know the common ratio is 4. We're trying to find the 7th term, so n is 7. So in the exponent, we have 7 minus 1. Deal with the exponent first. So we have 5 times 4,096. And simplifying that, we get 20,480. Now, in addition to finding a specific term in a sequence, we also want to know how we can find the sum of a geometric sequence. Remember, we're going to relate this later on to annuities, and so we want to be able to figure out, well, how much are you getting at a certain time? So say like in the 7th year, how much are you getting? But then you also want to be able to determine what's the sum of everything that you have all together. So if a geometric sequence has some first term, which we call A, and a common ratio r, then to find the sum of the first n terms, you can use this formula here. So S with sub n there represents the sum of the first n terms in the geometric sequence. Then we have A being the first term, r as the common ratio, and n is the number of terms. So take a look at example 2. Find the sum of the first 6 terms of the geometric sequence. Now obviously, you can absolutely determine what's the common ratio, and then find all 6 terms, and then add them all up. That's probably not too bad in this case, because you only have 6 terms. But what if you wanted to find the first 20 terms, what the sum of those first 20 terms were? That's going to be much more work if you go about doing it this way. So instead, we'll use the formula as long as you have the first term, and as long as you have the common ratio and the number of terms you're summing, you can use the formula. So in this case, we're summing the first 6 terms. The first term is 3. The ratio, the number that we're multiplying to get to the next term, looks like is 4. And then we're raising this to the 6th power because we're finding the sum of the first 6 terms. Simplifying 4 to the 6 minus 1 gives us 4,095, and multiplying and dividing gives us our answer here. So the sum of the first 6 terms of the geometric sequence is going to be 4,095. Now, again, you can verify this by finding the 4th, 5th, and 6th terms of the sequence and then adding those to 3, 12, and 48, and you will end up finding that your answer is 4,095. All right, the last example. Find the sum of the first 7 terms of the geometric sequence 128, 64, 32. Now this one is a little bit trickier. The reason is because, well, what are you multiplying by to get to each next term in the sequence? In this case, you have to think about this as not dividing by 2, but as multiplying by 1/2. So in order to get from 128 to 64, you're multiplying by 1/2, and then multiplying 64 by 1/2 to get to 32. Again, to find the sum of the first 7 terms, you can absolutely find the 4th, 5th, 6th, and 7th terms, and then add them together. The formula, though, allows you to find the sum of a number of terms much higher than this. Say, for example, you were asked to find the sum of the first 50 terms in this geometric sequence. You would definitely want to use this formula. So we are finding the first 7 terms, so n is equal to 7. The first term is 128. The common ratio is the number you're multiplying by to get to the next term. That would be 1/2 in this case, or 0.5. And we're summing up 7 terms. Simplifying this, we end up with this negative 0.992185. Multiply that by 128. Divide it by 0.5 minus 1. If you want to put that entire thing into the calculator, just be sure that you separate the numerator and the denominator in the calculator using parentheses. All right, and simplifying that, we end up with 254. So the sum of the first 7 terms in this geometric sequence is equal to 254. Next time, we will talk more about how this actually relates to talking about an annuity. But for today, just understanding a geometric sequence, how we get each next term in a geometric sequence, and how we can sum up the first n number of terms in a geometric sequence.